safadão!
Our solar system is one of over 500 known solar systems in the entire Milky Way galaxy. The solar system came into being about 4.5 billion years ago when a cloud of interstellar gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems, and one of those stars is our own Sun. Revolving around the Sun are 8 planets. The planets are divided into 2 categories based on their composition: terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small. The smallest and closest to the Sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago, when the planet had a watery surface and moist atmosphere. Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of the outer solar system. The Jovian planets include gas giants Jupiter and Saturn and ice giants Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain rock, ice, and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons, sport ring systems, have no solid surface, and are immense. The largest Jovian is also the largest planet in the solar system, Jupiter. Nearby is Saturn, the solar system's second largest planet. Its signature rings are wide enough to fit between Earth and the Moon, but are barely a kilometer thick. Past Saturn are the ice giants Uranus and Neptune. The slightly bigger of these ice giants, Uranus, is famous for rotating on its side. Next to Uranus is Neptune, the outermost planet in the solar system and also one of the coldest. Orbiting the terrestrial planets is the asteroid belt, a flat disk of rocky objects full of remnants from the solar system's formation, from microscopic dust particles to the largest known object, the dwarf planet Ceres. Another disk of space debris lies much further out and orbits the Jovian planets, the icy Kuiper belt. Apart from asteroids, the Kuiper belt is also home to dwarf planets such as Pluto and is the birthplace of many comets. Beyond the Kuiper belt is the Oort cloud, a vast spherical collection of icy debris. It is considered the edge of the solar system since that is where the gravitational and physical influences of the Sun end. Our solar system's particular configuration of planets and other celestial objects, all revolving around a life-giving star, make it a special place to call home.
This is the story of our Earth's formation 4.5 billion years ago, and of a little asteroid called Bennu, who's also survived until now. We have the team at NASA to thank for bringing us this video.
The Milky Way, home to billions of stars, rising and setting over billions of worlds, including our own. In this vast expanse, how did our Sun, the Earth, and the planets come to be? In recent decades, our understanding of the solar system's evolution has greatly improved, but deep questions remain. To answer those questions, astronomers are preparing to visit someplace very small. Asteroid Bennu. A lump of rock and organic material, the early building blocks of the solar system, of Earth, of us. Bennu is a time capsule, and its journey takes us way, way back, 4.5 billion years. The raw ingredients of Bennu and our solar system originated in a stellar nursery, a vast cloud of hydrogen, helium, and dust. Our own sun doesn't yet exist. Nearby are hot stars like this one, quickly burning up its fuel and destroying itself in a colossal explosion called a supernova. The explosion destabilizes our cloud, causing it to collapse. In the geologic blink of an eye, 100,000 years, gravity and angular momentum flatten the cloud into a swirling disk. In the center, where molecules crash together tightest, a protostar revs up to incredible pressures and temperatures. Deep within the disk, clumps of dust not much larger than a grain of wheat are flash heated into droplets of molten rock, called chondrules. The source of this heat remains a mystery. Chondrules are destined to become the building blocks of the solar system. Coaxed by gravity and turbulence, the chondrules clump. They grow into the first asteroids, into mountains, into planets. The asteroids are rubble piles of rock, metal, ice, and organics. This large asteroid is the parent body of Bennu, a protoplanet whose size we can only guess. Closer to the protostar, a planet begins to form. And then, dawn in the solar system. The protostar undergoes fusion and ignites, revealing our sun. But the solar system is far from finished. Jupiter most likely forms near its outer edge, but just 500 million years after the sun ignites, some believe that it slowly moves inward. Its massive gravity ripples the asteroid belt, disrupting countless asteroids and comets, flinging them toward the sun. They rain down on the inner planets, hammering and remelting large portions of their crust. Did these impacts also deliver organics and water, key ingredients for life? Back in the asteroid belt, Bennu's parent body is lucky. It survives this period of heavy bombardment. The solar system cools and calms. Jupiter and its many moons assume the orbits that we see today. Billions of years of quiet follow, more or less. Then 1 billion years ago, one theory suggests a collision shatters the protoplanet. Some of the debris loosely coalesces into a new, smaller body, Bennu. But Bennu will not stay in place. Dull, non-reflective, it slowly migrates toward the sun. Solar heating turns its warm side into a low-intensity thruster. Through millions of years, Bennu's orbit gradually tightens until it interacts with Saturn's gravity, altering its trajectory and hurling it into the inner solar system. Close encounters with Earth and Venus follow. Their gravitational tugs may have repeatedly stretched and reformed Bennu, turning it inside out and pulling off loose material. As a result, it has no satellites of its own, until now. Today, NASA is sending a spacecraft called OSIRIS-REx to explore Bennu and retrieve a sample. Why? Bennu has survived its long journey and settled into a near-Earth orbit, bringing its secrets within our reach. Now it is ready to teach us more about the solar system's history, its formation, its evolution, and our own place among the stars.